Hello guys, welcome back to Smart Interviews YouTube channel. Myself Jaren. Today we are going to discuss first three problems from Weekly Contest 405. Okay, so let's quickly jump into first problem. And the first problem is, let's go through the problem statement. The given problem statement is, you are given a string yes and an integer k. Encrypt the string using the following algorithm. For each character C, okay, so simply you are given string yes and an integer k. Okay, so you need to encrypt the string using the following method. So let's understand what is the algorithm. So for each character C in S, replace C with the kth character after C in the string in a cyclic manner. Okay. So return the encrypted string. So let's understand using the first example. Let's say S is nothing but that. This is a given string. And let's say these are the indices. And K is 3. Your resulted output should be something like this. So resultant output should be something like this. So simply your zeroth index value, it should be replaced by 0 plus 3. Okay. So zeroth character should be replaced by 0 plus 3. That is nothing but t. Okay. And first should be replaced by 1 plus 3. That is nothing but 1 plus k. That is nothing but 4. Okay. But 4, you cannot access it. And if you look at here in the problem statement, they mentioned in cyclic manner. So 4 means nothing but 4% of 4. That is nothing but 0. Okay. The value here, that is nothing but since it is cyclic, it points to 0. So D comes here and then A, then R. Okay. Now this is the input and this should be the required output. Okay, everyone clear with question, I guess. Now let's see how we can solve this. Okay. Now, how we can solve this problem? So simply, can I say something like we can have some resultant string and every time, where you should start. Yes or no? Let's say K is 3. You should start from 3 directly and every time insert into this resultant. So the character at index 3 is nothing but T. Insert it. Then move forward. When you move forward, whenever you cross n, value n, when it is going to n, simply apply, let's say previously I is nothing but 3. Now it is 4. When it is 4, you cannot access it. So simply apply percentile n. Okay. So every time when you are increasing I, apply percentile n. So when it is 4, it becomes 4% of 4, that is nothing but 0. Then insert D. Then again increment from 4, increment 5. Again apply percentile, that is nothing but 1. Insert into a result. Then 6, apply percentile and insert it into result. Finally, from where you should traverse this? Can I simply say you should traverse from K to n plus K? Yes, sir. K to n plus K minus 1. Yes, sir. 3, 4, 5, 6. Something like that. Okay. So this is the approach. I hope you guys are clear with the approach. Now let's quickly write code for this. Okay. Let's quickly write code for first problem. Now, what's your approach? Simply you should traverse from K to n plus K minus 1. Okay. So let's take n. So what is it? N is nothing but length of string. Then what you need to store it in some string. So let's take it resultant string. Okay. And let's traverse from I equals to K to I less than n plus K. And every time we need to take care of I value. Sometimes it may exceed n. So in this scenario, let's take J and let's apply I percentile n. And every time what we should be doing, we should push this off into the result. Then finally return result. Let's run the code. Okay, that's it. And let's quickly start with second problem. Now, let's go through problem statement. You are given a positive integer n, a binary string x. Okay, a binary string x is valid if all the substrings of x of length 2 contain at least one word. Okay, return all valid strings with length n in a not. Okay, so simply he mentioned that x is a string, and if it is valid, if it is having at least like one in the substrings of length 2. Okay, let's say if you are having some string like this is not valid. Why? Because if you take the substring of length 2, if you consider this substring, it is not having at least one in it. Okay, so it is not valid. If you consider this string, this is valid. Why? Because if you consider any of the substring of length 2, at least one is present in it. Okay, so let's go through first example. The given first example is nothing but your n is 3 and how many substrings can we generate? So simply can you tell me how many strings can we generate of length 3? Okay, the binary strings will be nothing but 000, 001, 010, 011, 100, 101, 1110, and 11. All these strings are possible. Now, in this, if you observe, is this valid string? If you observe, one is not present in two substrings of length. So this is not valid. Now let's move forward. This is not valid. In this length, if you consider this substring, it is not having one in it. So this is also not valid. How about this substring? It is valid. How about this string? It is valid. This string it is not valid. And rest of the strings are valid. Okay. So if you observe, all these strings are present in this order. So how will you generate all these strings? So can we solve this using simple regression? Yes or no? If you observe, after 1, you can have either, let's say if you are having 0, if you are starting string with 0, after that you should definitely have 1 to be your, for getting a valid string. Yes or no? After 0, definitely should have 1 to get a valid string. For 1, if you are having 1, after 1 you can have either 0 or 1. It will be valid. Yes sir. So simply, what can be your approach? Let's say n equals to 3. N equals to 3. And you can start with either start your string with 0 or 1. You will be having two choices. If you're starting with 0, the next string should be definitely, sorry, the next character should be definitely 1. Whereas if you're starting with 1, the next character can be either 0 or 1. Again for 1, if you're if you're having your character as 0, current character as 0, next character can be either 0 or 1. So this is of length 1, this is of length 2, and this is of length 3. Similarly here, after 0, you should definitely have 1, and after 1, you should definitely have 0 and 1. Every time, when you keep constructing this string, whenever you come across the length n equals to n, you store it into some vector. Okay, you can directly push it into vector. So you'll get something like this from this, and from this you'll get 101 and 110 and 1. Okay, finally you can return the vector. I hope everyone clear with approach. Let's quickly code it. Okay, let's quickly start with coding. So firstly, what we need? We need to return a vector of strings. For that, let's create a vector of strings. Now, every time you need to have a string. Okay, so let's create string. And you're writing recursive code, you need some recursive function. So let's name it as solution. And as of now, let's keep the return type as what. So every time, simply what you are doing, You are making function call solution and you're passing character 0. This is the first function call. And again, you're passing function 1. And every time you are trying to store the string, resultant string that you're getting in answer, and you're using string s to construct that. Okay. And you should know, but at what time you should stop, keep traversing. Okay. So for that, you need length. So these are the parameters. Same for here. Okay. Now at the end, simply what we should be doing, we should return answer. Now before calling this function, firstly we need to insert 0 in the string. Okay. So let's say s dot push back 0, and after the function call, you should clear this to again push 1 into it. Okay. Sorry, my bad. Again, after popping, you need to push 1. Okay. So let's say when you're having 0, let's go through this function call. So firstly, you need to pass vector of strings, and then you're passing a string s, and then you're passing in, and then you're passing a character, previous character, to identify what is the previous character, so that you can make decision whether to push 0 or 1. Okay. Now, so firstly, based on previous character, we'll be making our decision. If our previous character equals to 0, then what we can do, we can only push 1 into it. We will not be having any other choice. So simply we'll push 1 into it. Else, if it is not 1, if it is 0, then what you can do? You can push 0, then you can push 1. Both you can push. Okay. And now what about base condition? Simply if string length becomes n, you simply push string into answer. Then you can return from there. Okay. Now let's run the code. Let's submit it. That's it. Okay. Let's quickly start with the third problem. Now, what is the problem statement? So given a 2D character matrix grid, okay, where grid of ij is either x or y or dot. So return the number of submatrices that contains grid 0, 0, okay, and an equal frequency of x and y, and at least one x. Okay. So you need to return number of submatrices that should definitely have these three things in it. Okay. So let's see the first example to understand the problem statement better. Now this is the given grid, and it looks something like this: xy dot and y dot dot. So if you observe, this is one substring. Sorry, this is one submatrix having 0, 0 in it. Okay, 0, 0 in it, x in it, and xy. Equal number of xy. X is present and 0, 0 is present. You can also have this submatrix where x and y is present, x is present, 0 0 is present, and x and y are equal frequency. Similarly, this as well. Okay. So total three submatrices are possible. Okay. Now we can also look at example two where xx and xy. So simply, if you start from, if you look, if you're having 0 0, but you cannot have submatrix where equal x and y and at least one x and uh, submatrix starting from 0 0 is present. Okay. So only, sorry, there are no submatrices. So 0 is written. Okay. Same for the example 3 as well. So let's take one more example for getting our approach. Okay. Let's take some example like this. Let's say this is a given matrix. Okay. Now you need to calculate the number of submatrices. So simply, can you tell me how many submatrices are present? Firstly, can I say some, this is one submatrix where equal number of x and y are present, x is present and 0 0 is present. Similarly, can I say this can be another submatrix? Yes or no? Similarly, can I say the whole matrix can also be considered? Yes or no? Where 0 0 is present, equal number of x's are present, equal number of y's are present, and x is present in it. Yes or no? So let's do one thing. Okay, let's simplify this further. Instead of having dots and x and y, let's have, instead of dot, let's have 0. Let's take another, you know, another matrix. Let's name it as pre. Here we are going to pre-compute our values. So let's, instead of dot, let's take 0, and instead of y, let's take -1, and instead of x, let's have 1. Let me write it here. Okay. So let's take a pre-computation matrix of size n cross n, and initially it will be having 0, 0, -1, 0, and instead of x, have it 1, take 1, 1, 1, -1, and 1, -1, -1, 0, and 1. Okay. And let's say these are the indices. Now, let's do two things. One is we are going to transform this matrix into something like this. Okay. So, firstly, we will keep traversing through each row, and every time we will be adding the previous element. Okay. So, that is nothing but 0. Let's consider the first row. Okay. This is our first row. Now, let's start from here. Add with previous element 0. Okay, add with previous element and this 0, and 0 -1 is -1, and -1 plus 0 is -1. Again here 1 plus 1 is 2, and 2 minus 1 is 0. Okay, and 0 plus 1 is 1. Okay, then again -1 -1 -2, -2 plus 0 is -2, and 1, sorry, minus. Okay, this is first transformation, and we are doing it in this direction. The next transformation is something like this. We should do it in this direction. So initially, consider the first one in first column. Keep adding with the previous column. So 1 and 1 and minus 1 will be 0. Same here. 2, 2 and minus 2 will be 0. And minus 1 plus 0 will be minus 1. And minus 2 plus minus 2 will be minus 3. Then minus 1 plus 1 will be 0. And 0 and minus 1 will be minus. Okay. So simply, if you observe this grid, previous grid across CM, your grid is something like this: dot dot y and dot, then x x y and sorry y and x and y and dot and x, something like this. So if you observe here, this zero represents zero number of zeros, and okay, so this zero represents, that means till here only one grid is there. Sorry, no x and y are there. So if you consider this subarray, okay, till here, if you consider one, there is no zeros and ones. Sorry, there is no x's and y's. And if you observe this, if you consider this submatrix, then you are having 1y. That is the reason why you are having minus 1. Again, if you observe here, minus 1 is there. That means in this submatrix, you are having only 1y. That is the reason why directly you can access it here. That is minus 1. Only 1y is present till here. Now again, if you observe here, you are having 1. That means in this matrix, you are having only one x. Okay, and if you observe this number 2, that means in this matrix you are having two x's. Okay, so if you directly access this, okay, my bad, sorry, small mistake here. So 1 plus 1, 2, okay, and 2 minus 1 will be 1, and 1 plus 1 will be 2. So this will be 2, okay, and here it will be minus 2 plus 1 will be, this is correct. Again, here what happens? 0 plus 2, fine. In this minus 1 plus 1 will become 0. Okay. And minus 1 plus 1 will become 0. And plus 1, this will become minus 2. Okay. Once this become minus 2, this also will become minus 1 plus 2 will become 1. And 1 plus minus 1 will become 0. Okay. Now, let's move forward. If you observe, here you are having 0. That means in this submatrix, you are having equal number of x's and y's. Okay. Similarly, if you observe 1, here 1 means in this submatrix, you are having 1 extra x. Okay. And here, if you are having 0, that means in this submatrix, you are having equal number of x's and y's. Again, this 0 represents this submatrix also have equal number of zeros and ones, and this minus 2 represents you are having two extra ones, and this 0 represents you are having in this matrix you are having equal number of zeros and ones. Is it clear? That is the reason why we pre-computed. But if you observe, uh, along with 0 0 having 0 0 index value and also equal number of x's and y's, you should also take care of whether x is present or not. Okay, so let me tell you. So if we consider this 0, that means it is having equal number of x and y's. Also, that means It might be a dot, right? Here, if you consider, if you observe, it is a dot, and it doesn't mean you are having at least one exit. So, can you have it as your submatrix? Can you consider the submatrix? No, right? So, for that, you should also take care of number of x's. So, along with the pre, let's maintain another matrix that is nothing but, let's say, check, okay, or exist to take care of whether x is present or not. Initially, let's initialize to false, except for places where we don't have x. Okay, initially everything will be false except from where x is present. So true, true, false, false. Sorry, this will be true. Again, false, 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 and again this will be modified something like this, similar to previous. This time we should apply or operation because at least one x is present, then we can consider it as valid. So we'll be traversing in this direction. Initially, you will be having 0, 1, 2, and you'll be having 0, 1, 2, 3. Okay. Initially, this is false, true, false, and we'll do or with previous. So it will be false again, false or false, again false, again false. Here, once you got true, everything will be true here, and here false, false. We're traversing in this direction. Don't get confused. This will be true. Now we need to take care of this direction. Okay. So again, 0, 1, 2, and 0, 1, 2, 3. Okay. Now false. While going down, we'll make it true and true. Again false. While going down, you'll make it true and true. Again false. While going down, you'll make it true and true. Again false. True, true. If you consider any of the submatrices where you are having true, then you definitely had x before it or in that particular place. Okay. So using these two matrices, what you can do, you can simply keep traversing with the pre. Okay. So simply what you can do every time, you can keep traversing and you can check whenever your pre-matrix is having 0 and having true. Let's say consider 0 comma 2 comma 0, whenever you're having true and 0, there you can simply make the count. Okay, so let's say you're having count variable, so you'll be traversing every time when it is true, and every time it is true and 0, that means this scenario, your count will become 1. Again true and 0, that means this is another scenario, your count become 2. Again here, your count will become 3. Again here, your count will become 4. So this way you will get your answer. Okay. So total four submatrices. So four submatrices are present. Now let's quickly jump into the coding. Okay. Let's quickly write code for this. So firstly let's take dimensions of matrix are n and n. So n will be nothing but grid dot size, and n will be nothing but grid of 0 index dot size. Okay. Now firstly, we need to construct two matrices. One is for pre to maintain frequency, and other is for whether to check whether X is existing or not. So, of integer matrix, let's name it as pre, and let's say we will be having something like this. Let's initialize the values at 0. Then again vector of boolean, and we should check whether it let's name it as exist. Now, firstly, let's fill the values in tree and exist. Okay, so let's run a for loop. So every time if grid of ij, if it is equals to x, then we should make pre of ij to 1 and exist of ij to true. Okay. Also, let's say else if grid of I j contains y, then we should simply make previous of pre of ij to minus. Okay, we are done with initialization. Now let's populate the values in pre and exist. Okay, so firstly, uh, in the left to right direction that I mentioned while explaining it. So for that, for I equals to 0, we will be traversing to each and every row, and we'll be traversing from j equals to 1 because we need previous value, there is nothing to do it, 0 it is. Okay, j plus plus. So simply what we will be doing, pre of ij will be nothing but pre of ij plus pre of I j minus 1 and exist of I j equals to exist of ij or exist of I j minus 1. Now from top to bottom, for int j equals to 0, for int I equals to 1, I less than n, I plus plus. Again, pre of ij equals to pre of ij plus pre of I minus 1 of j and exist of ij equals to exist of ij or exist of I minus 1 j. Okay, and we are done with pre-computing the values. Now we need to calculate the number of submatrices. So for that, let's take some variable. Let's take some answer variable, and we need to again traverse through the entire matrix. Okay, and simply we need to count when we need to increment the answer whenever we are having two conditions. What are they? One is pre of id should be 0, that means equal number of frequency. At the same time, you should have at least 1x. So that is nothing but exist of ij should be equals to 0. And finally, return answer. From this, and let's submit this. Okay, and if you feel this video is helpful for you, please consider liking this video, share with your friends, and please subscribe to the Smart Intelligence channel. Okay, thank you.